Students of class 11th, today we will study the difference between bonding and anti-bonding molecule orbital. ये हम पढ़ेंगे क्योंकि this comes in the examination. Bonding and anti-bonding molecule orbital. So first of all, first difference in bonding molecule orbital, these are formed by additive effects, effect of atomic orbitals. जैसा आपने पढ़ लिया, in case of bonding molecule orbital, you have read that आपने लिखा था psi symmetric is equal to psi A plus psi B. So यहाँ पर जो symmetry में जब आते हैं, when the electrons come in the same phase, wave comes in the phase, so there takes the additive effect. So bonding जो orbital वजूद में आता है, that orbital is called the bonding orbital. So this bonding orbital, we know that bonding molecule orbital is formed by additive effect of the atomic orbitals. That means psi symmetric, वहाँ पर हम लिखते हैं psi A plus psi B. तो this is formed by the additive effect. Now इसके बाद if we take the case of anti-bonding molecule orbital, anti-bonding molecule orbital जो है, that is formed by subtractive effect, is formed by subtractive effect, because there occurs subtraction. For example, you psi asymmetric हम जिस लिखते हैं, so that equals psi A minus psi B. We subtract the wave functions. So बाद में हम scattering करते हैं. So here we subtract the wave functions. यहाँ in the bonding orbital we add the wave functions. Number second, in case of bonding molecule orbital, you have read that the probability of finding the electron in the molecule orbital is greater. That means the electron present in the bonding orbital जो है, density within the two nuclei जो है, electron density increases. that is electron density जो है, electron density increases in the region between the nuclei. जब जैसा आपने पढ़ लिया कि probability of finding the electron in the molecule orbital is greater, उसका मतलब है that electron density increases in the region between the nuclei of the two atoms. जो combining atom उनके जो nuclei आपस में combine होते हैं, so जो नया molecule orbital बनता है, that is polycentric. तो इसमें electron density increases in the region between the two nuclei. And in case of anti-bonding orbital जो है, probability of finding the electron in the anti-bonding orbital, in the anti-bonding molecular orbital is less. इसका मतलब है electron density जो है, electron density decreases. Electron density decreases in the region between the two nuclei in the case of anti-bonding molecule orbital. Electron density decreases in the region between the two nuclei of the anti-bonding molecule orbital. So number third, if we take the case of, for example, because of the यहाँ पर जो additive effect होता है in case of bonding orbital, this results in the attraction of electron. This results यहाँ पर जो electron की results in attraction of electrons. Attraction जो attractive force comes into play. So ऑफ इलेक्ट्रॉन्स. सो विद द रिजल्ट जो एनर्जी जो होती है, एनर्जी ऑफ द बॉन्डिंग मॉलिक्यूल ऑर्बिटल जो होती है वो लो होती है. एनर्जी दिस रिजल्ट्स इन द अट्रैक्शन फोर्स ऑफ द इलेक्ट्रॉन्स एंड एनर्जी ऑफ द बॉन्डिंग ऑर्बिटल जो होती है इज लो. जब लो होता है दैट मीन्स इट इज स्टेबल. सो यहाँ पर जो एंटी बॉन्डिंग में है दिस रिजल्ट्स इन द रिपल्शन. यहाँ पर रिपल्सिव फोर्स आता है, रिजल्ट्स इन द रिपल्सिव फोर्स, रिजल्ट्स इन द रिपल्शन ऑफ इलेक्ट्रॉन्स. यहाँ पर इलेक्ट्रॉनों की रिपल्शन होती है. सो इसका मतलब है एनर्जी जो होती है इन द एंटी बॉन्डिंग ऑर्बिटल एंड एनर्जी इज हाई, इसकी एनर्जी हाई होती है. इसलिए दिस बॉन्डिंग ऑर्बिटल जो होता है दैट इज स्टेबल एंड एंटी बॉन्डिंग जो होता है वो अनस्टेबल रहता है. तो bonding orbitals, these are designated by sigma, or these are designated by pi, or these are designated by delta. And in case of antibonding, you have read that it is designated by sigma asterisk, pi asterisk, or it is designated by the delta asterisk. So this is why the some differences between the bonding and the anti-bonding molecular orbital. Now we will proceed towards, I will show you example. For example, we will take the energy level diagram on in case of this molecular orbital theory. We will take the formation of, for example, I will show you formation of, for example, nitrogen molecule. This comes in the examination, formation of nitrogen molecule. So in case of nitrogen, nitrogen atomic number it is 7. So it has electronic configuration. I will write it is 1s2, 2s2, and it is 2px1, 2py1, and z1. That means in case of nitrogen molecule there are 14 electrons to be accommodated. Now I will show it in the here. Now I will write this is the energy level, this is the increasing energy, increase in energy. So first of all I will show, let is the 1s orbital, and again 1s orbital of one nitrogen. Let this nitrogen first, and this is another nitrogen. So in case of nitrogen there are 2 electrons in 1s orbital. There I will write it is 1s of one nitrogen, this 1s of another nitrogen. So these 2 electrons, for example, I will write, show it here. There are 2 electrons. Now these 2 electrons, there are now total 4 electrons. These 2 orbitals will combine and they will form 2 orbitals combined, they form here 1s of orbital of one nitrogen and 1s orbital of another nitrogen. They will form 2 orbitals. So I will show one will be the bonding and other will be the anti-bonding. I will show this. Now there are 4 electrons. 2 electrons will go into the bonding orbital first, which has lower energy. I will write it as sigma 1s. There are electrons, 2 electrons. And in case of anti-bonding orbital, it will all they will there will be go anti-bonding. There will go 2 electrons. Now that means 1s electron have left. Now there are now the electrons in the 2s. I will write it here. This is 2s. Now there are 2 electrons. So in here there are also 2 electrons and another nitrogen. So I will combine these 2 orbitals. So that means they will form these are 2s of one nitrogen and 2s of another nitrogen. They will combine. Here there are 2 electrons and another there are 2 electrons. So they will form 2 orbitals. One will be the bonding and other will be the anti-bonding. Bonding orbital. Now there are 4 electrons to be accommodated. 2 electrons will go in the 2s bonding orbital and 2 electrons will go in the anti-bonding 2s orbital. So this will be sigma 2s and this will be sigma asterisk 2s. This will be the bonding and this will be anti-bonding. I will join these orbitals to have a diagram. Now this is, so in this way we will make the energy level diagram. Now this is the bond. Now we are left with 3 electrons in the p orbital. So in 3 electrons in one, there are 3 electrons in, I will write it there px, py, pz. So there are 3 electrons in the one in X, one in Y, and one in Z. So 2px, 2py, 2pz. So one electron here, one electron in this. And similarly, in another nitrogen atom will come, there will be also 3 electrons. So these are 3 electrons. Now they will combine. There are 6 electrons, 3 orbitals combine. They will combine. First they will form, I will show 2 orbitals here. It will be pi x, pi 2px आ गया 2 pi और y orbital, then x and y will combine, and then z has higher energy. So it will be pi x, 2px is यहाँ पर pi 2py. So there are how many electrons? There are 3 orbitals, 1, 2, and 3. There are electrons. Their electrons are 6. So each orbital will get 2 electrons. After that, now anti-bonding molecule orbital will be formed. Anti-bonding molecule orbital forms. So it will be pi s and pi z. Now, since they will not get any electron because there were only 6 electrons. They are accommodated in them this pi 2px and pi 2py and this sigma 2pz. So no electron will enter the anti-bonding orbital. Now, how many electrons are in the bonding? Now we will see. There are bonding. There are 2. 2 are 4. There are 2, 4, 6. There are how many electrons? 2, 2, 4, 2, 6, 8, 10. There are 10 bonding electrons, and anti-bonding there are 2, 2 are 4, 4 are anti-bonding. So there are bonding electrons are 10 and 4 are anti-bonding. So we will write here now bond order. What will be the bond order? So bond order is defined as is equal half of the difference of number of electrons in the bonding orbital and anti-bonding orbital. I will write it. Bond order is half of the difference in the number of electrons in bonding and anti-bonding orbital. अब anti-bonding और bonding orbital में जो डिफरेंस आ जाएगी उनका हाफ जो है वो बॉन्ड ऑर्डर. सो हमारे इन केस ऑफ नाइट्रोजन विल राइट एंड बॉन्डिंग नंबर ऑफ इलेक्ट्रॉन्स इन द बॉन्डिंग इज 10 एंड एंटी बॉन्डिंग में नंबर ऑफ इलेक्ट्रॉन्स इन एंटी बॉन्डिंग इज 4. So there I will write it as a bond order is equal to 1/2 of 10 minus 4, that is 10 minus 4 is equal to 6. So 1/2 of 6, so it is 3. So bond order in case of nitrogen is 3. Now you have seen, I will show you the diagram again. Since there are all the electrons are pure, there is no unpure electrons. That means if there are all electrons are pure. All electrons are pure. So we can say that when an atom has pure electrons, that it is diamagnetic in nature. So it is diamagnetic in nature. Nitrogen molecule is diamagnetic because all the electrons are pure, so it is diamagnetic. If there is any unpure electron, for example, if we take the in case of the N2 negative, that will be paramagnetic because of that one electron will go to the another, that will remain unpure. So any substance, any molecule having pure electron will be diamagnetic, or if there is unpure electron, then it will be paramagnetic. So nitrogen is diamagnetic. So by this you can you can make that all the diagrams of the energy level diagrams. Now we will write the electronic configuration of the molecule. Students, I will write first, for example, here in bonding orbital there are 2 s electrons. So I will write it is sigma 1s, sigma 1s2, sigma 1s2. इसके बाद हम sigma s एंटी बॉन्डिंग में 2 आ गए. So sigma s 1s2. इसके बाद 2s sigma 2s2. तो इसके बाद सिग्मा एस्ट्रैक्स 2s2. तो इसके बाद हमारे पास आ गया ये y वाला. सो दैट विल बी सिग्मा, दैट इज पाई 2p x2 पाई 2p y2 एंड इसके बाद सिग्मा z orbital comes along the internuclear axis, that will form the sigma bond, so that will be sigma 2pz2. Since there are no electrons in the antibonding orbitals in the x or y or z, so that it does not need to be written. But we will see here, since first shell is K shell and it is complete, we write it is simply KK, that it is closed shell. When we write the closed shell, that means it is non-bonding, that means it does not take place in, it does not bonding does not take place. We say closed shell, that is KK means closed shell. Then we write KK, so that means first shell is complete. Then we write 2s2, sigma 2s2 and sigma sx2s2. इसके बाद sigma 2s2 and sigma sx2s2 and same pi 2px2, pi 2py2 and sigma 2pz2. But first we should write, if the first shell is complete, then we write KK, that means closed shell, that K shell is closed, that then it's called the non-bonding. So this is, by this we can write the electronic configuration of the this nitrogen molecule. Thank you.